Hello. Hello. Hey everybody. Just watching the kitty back there. She's just been telling me something. I don't know what. She was fast asleep and she started moving around a little bit and started talking. And just moments before we started here, she was talking, and now she's looking a little confused. So, hey, welcome everybody. Welcome again to Astronomy Daily Live. So here we gather together pretty much every single day at 2 hours UTC, and we think and talk all things astronomy and space and science and all kinds of nerdy things, whatever we want, right? We can go off on tangents on occasion, right? No problem with that either. I can't believe that this is the this live stream is going out at 2:01 UTC on the 31st of March 2019. So it's the last live stream of the month of March 2019. And going into March, I sort of look back, and January and February seemed really long, right? Like super long. Like it took forever to get to March 1st, which was great, right? But this past month, for me at least, has really zipped by. I mean, I don't remember much. It went so fast. So, yeah, I don't know what that's all about. And yeah, it's probably a perception thing because you may have almost exactly the opposite experience, right? That it just drug on and on and on, and it's finally over, right? So, but yeah, for me, it's been an unusually fast month. Oh, no location provided. Well, of course, Mr. Nightbot is not going to work if we don't do that. Now, I saw Bobby pop in, but then he popped out. So I don't know what's going on with him. But yeah, this is just a fun, casual get-together of friends from around the world who come together and share a common passion for astronomy, as I said, and space and science and all the nerdy things that make the world go, right? If it wasn't for the nerds, we would not have the pretty amazing array of things and we probably wouldn't have the kind of knowledge that we have, right? I guess we would have a different one. Yeah, there's Patrick Manny. Look, it did that again. It did Chelyabinsk. That is really bizarre. I'm not, I'm not quite sure why Nightbot thinks that zip code is Chelyabinsk. I'm just not understanding that one. I think Patrick, I think you tried that before, and okay, well, that explains it then. I mean, that exactly explains it. Here are my short thoughts on contests, right? I think, what is the ultimate goal of a contest or some kind of you know, one team against another, or you know, anything like that. What is the goal, right? Well, the goal is to win, right? So I think that hey there, Astro Live channel, nice to see you, and Chuck, hey, cheers, yes, casual get together. This is the hydrogen hydroxide again. Bobby is having technical difficulties, but it looks like he is popping in. Bobby, come in, Bobby.
Hey!
There you are. Hey, what's going on?
Yeah, got a little bit of a technical botch here. I had to like rewire the whole kit caboodle. I had to untangle some wires, and then I think everything just went berserk, and then I had to reboot the computer.
That's awesome. Yeah, you know, wires. I've worked with a lot of wires in my life. You know, when you're dealing with astronomical instrumentation, there are wires everywhere, right? Wires and cables and you know, things, right? But lots and lots of wires and cables. And when I was involved in like doing, you know, the early adaptive optics work up at the multiple mirror telescope, um, uh, I uh, I was the only one that was willing to deal with the wires and the cables. Um, and what I observed and what actually made it, you know, you know, given the will, I think that we can psych ourselves into anything, right? So I don't know if this is me psyching myself into doing this, but what I observed is that these wires and cables have some kind of of ability to tangle. You can be, you know, pretty much as careful as you can possibly be laying out, you know, wires and cables, and for some reason, when left alone, right, when completely left alone, they end up, you know, twisting and getting completely tangled, and you know, it's a mysterious enigma that I was the only one that was willing to tackle. So at the observing runs, I would be in charge of not only, you know, my piece of you know, the entire project, but I was always elected, you know, the wire guy. So I had to take all the wires and cables out of the boxes and, you know, connect them all up and all that, and it was absolutely fascinating to me how tangled those cables could get. It it you know, most of the time, uh, when you get a, you know, twisted up cable, it's sort of a frustrating, painful thing. You know, you get angry and you know, you throw it down and all that. See, I've turned that around. I'm absolutely amazed by how incredibly tangled wires can get, and they seem to do it all by themselves. So, you know, what's up with that? You know, I think that something should be studied, because it's really an amazing thing. I really think that they have some kind of like, you know, a mischievous plan, you know, just to mess with us humans, right? I think so, and I think they're having a great time with it, because man, they just drive us crazy. But I thoroughly enjoy it. So you know, if you ever have anything tangled that you want untangled, right? You send it to me, and I will take care and I will take care of it, right?
I like that. I like that.
So because I thoroughly enjoy that kind of a challenge. It's like a puzzle, and it amazes me how these things do what they do. It just blows me away. Anyway, hey there, Earth Radio, Ron. Hey, what's going on?
How you doing? I haven't been by much because I've been working a lot on the radio, so
Yeah.
been kind of busy.
Is there a show going on right now, Ron? I can pretty much turn it on my Fire Stick.
There might be in a little bit. Yeah, I got quite a few different people that like to play, but Cosmic Lettuce, I was going to ask you if you could do a special birthday tune for Bill, New York Skywatcher.
Absolutely.
His birthday is Monday.
It's Monday.
Yeah,
okay.
April 1st.
do you want just the traditional happy birthday song, or do you want something else?
However you want to make it, your choice.
Ooh, okay.
Think of what he does. Think of who he is. Think of how much he loves life and everything like that, and then make it a nice little song for him.
Okay.
It could be short. It could be sweet. It could be funny. It could be whatever you.
I got you. Okay.
However you want to make it.
I definitely cannot make any kind of promise.
Okay.
But the gears are already beginning to work.
I just thought it would be a nice little gift and touch, for
now,
his birthday.
I don't know Bill as well as you do.
Right.
I have noticed that a lot of people really like him. That says a lot, right?
Yeah.
He
is a skywatcher. He does astronomy, sky and things like that. So he's kind of like what you do. Of course, you get paid for it, but he does it on his own and has fun with it. And then he does the radio producing on the other station. I won't mention the name right now, but
gotcha.
Everyone knows if you know who he is and you know what I'm talking about.
That's K. What is that?
KGRA. I won't mention it since you asked.
Yes.
KGRA radio. Yeah.
Yeah, and it's KGRA. Radio.com, is that right?
I think it's digital broadcasting, DBC.com or something like that.
Okay.
KGRA DBC. You can look it up on Google, and it'll come up on the top of the list if you just put in KGRA. And then,
I know. Right, I know. Mark Antonio does an astronomy thing Sunday evenings.
Usually, of course, he's been at the conference for the last few weeks, so he's not been here to do it.
I see.
They've had reruns or they've had pre-records or whatever.
Cool.
But yeah, I know Mark also and met both of them, and really super guys that you could ever ask to be on your side.
Absolutely. I've contacted Mark and he's expressed an interest in some kind of collaboration at some point.
There you go. And I think he's moving to Arizona soon.
Yeah. Well, I don't know if he exactly has any kind of timeline. I think he from what I remember hearing him talk about, he is looking for land like up in the Sedona area, which is sort of the middle of the state.
Yeah.
And from Sedona to where I am, that's about a 4, maybe 5 hour drive.
Oh, okay.
So it's pretty far.
Yeah. And it's different driving in the desert.
It's
different desert, right? Each different in the desert. You know, the driving's got to be different.
the driving is either extremely boring.
Oh yeah.
Or extremely just like, wow, I cannot believe where I am.
That's kind of like me with the cornfields here. You know,
yes.
You see cornfields for miles and miles, and it's either that looks really cool or that like, what the heck am I doing? You know?
Yes. Well, I can say that the state of Arizona, the entire state, really looks a lot like Mars. When I look outside my windows here, right, if I were to get rid of the vegetation and the houses and the car, all that, it would look literally identical to Mars. All the scattered rocks everywhere, the shapes of the mountains around here, it looks just like Mars. So it's very, very cool in that way. Yeah. Wow. And most of Arizona is something like that. Yeah. Right. So yeah, it's and there are some really dark areas, which is, I know why he's extremely interested in getting a telescope over here. I think, as I recall, I think his plans are to put an observatory in sort of the Sedona area, but maybe live somewhere else. I'm not quite sure. Yeah, I don't recall exactly. But yeah. So he's got a radio show on KGRA. Is that it?
Yeah. Yep. KGRA, and usually it's on Sunday nights at what is it, 8 o'clock?
Mm-hmm.
And 8 to 10, I think it is, and or maybe 7 to 9. I don't know. I get them mixed up. They switch. They gave them a 2-hour time slot now, so I can't remember when they actually start.
Oh, all right. Yeah.
Might be 7. No, 8 to 9. 8 to 10, I think it is.
Right.
Yeah.
I gotcha.
It is a 2-hour time slot, though. Yeah. So, when you can, and when it gets back to the live show, I'd encourage you to check that out if possible. And if you can either check out a replay or whatever, later on, just look at some of them right now and just, see what he talks about.
Right.
He's very involved with the exoplanet research.
Okay.
So,
what do you know? What he is doing in terms of that? Is he making observations? Is he looking at data?
Yeah. He's making. I think he's making physical observations, and he's researching, of course, the data that he finds or that anyone else finds.
Right.
But like they're talking about the one that had the giant star that was probably 10 times bigger than our sun, and it has like 7 planets around it or whatever,
Mm-hmm. Yeah.
And I can't remember the name of the star now, but anyway, it's one of the big ones. But it's something that they were looking at that has a possible planet like Earth that, of course, is way bigger than what we are, because of the size of the star and everything like that. So I just don't quite know how we could even get there, because it's quite a ways. Quite a ways.
Yeah, that's a challenge.
But just find another star with planets around it, in our similar situation or how we are.
Oh yeah.
Like, wow, that's incredible, Cause
how
many years ago we didn't even think about it. I mean, we might have thought about it, but we really didn't anticipate on finding anything.
Yeah, well, the first exoplanet was discovered 1995, 1996. Yeah. So I mean, it's only been what, 20 some years, and we have barely scratched the surface.
Right.
Yeah. So I think these kinds of things, I mean, I understand are exciting, right? But I am not surprised in the least that there are planets around every single star.
Right.
I have, I'm just sort of like, well, yeah, so I mean, I think it's really, really neat. It gives us, a lot of new and interesting data, and everybody is so excited about trying to find life, right?
Yeah.
I don't know, I don't know why astronomers are interested in living things. Biologists, right? Biologists are the ones that are kind of interested in life. Why do astronomers get so excited about trying to find life? I don't get it. Uh, but I mean, that's a good motivation, I suppose. But yeah, our technology is evolving, and it's evolving at an exponential rate, right? And so we those capabilities to be able to make these kinds of measurements are going to get easier and easier and easier and easier to do, right? So one of these days we're going to have telescopes acting as interferometers that are astronomical units in size, right?
Yep.
And when you have that kind of an aperture, right, you're going to be able to see the eyelashes on the aliens on those planets.
Right.
Right?
How big is the Hubble telescope? Is it like 28 inches or 200?
No, it's 2.4 meters. So it's
I
about
was close.
Yeah. So I think it's about like 90 inches
or
so, something like that. Yeah.
Okay. So that's now. Is that
it's not very big. It's small
compared to the space. Yeah, I guess so. Is that a flat mirror, or is it a what they call a concave mirror, or a regular catadioptric type of thing?
Yeah, all telescopes, reflecting telescopes, use some kind of a concave primary mirror.
Okay.
Yeah, I think I can safely say that. So yeah. With the case of the HST, the problem that they encountered after they launched it, right, is that they got the shape of the primary mirror wrong, right? It's not supposed to be a spherical shape. It's supposed to be a parabolic shape.
Oh.
And they sent it up there as a sphere, and it doesn't focus.
Right. And that's why they couldn't get it to focus correctly.
That's right.
And they realized that when they're looking at what was that one?
Yeah.
Yeah.
Oh yeah. No, I mean it was extremely odd.
The one group of galaxies I can't remember, and they were trying to find out the lensing effect, and that's when they discovered they couldn't focus on something.
Yeah, I've got to say that probably happened the moment they saw the first image.
Oh wow.
Oh yeah. I mean,
they actually had to send someone up there to repair it.
They did.
Wow.
They came up with a brilliant optical solution that yeah. I mean, it's basically that, but some kind of crazy solution, right? That did it. I mean, it's absolutely fantastic.
That is. So that thing is floating. I don't know. That thing makes my house look small, obviously.
It's actually I would say it's much smaller than a house.
Really? Okay.
It's more like a bus.
Oh, okay. Okay.
Mm-hmm.
All right.
Yeah, it fit
All right.
inside the space shuttle, right? So the space shuttle lengthwise is about as long as a DC-9,
Okay.
right? So I mean, it's pretty small,
Okay.
right? So your the HST, I think, is about the size of a bus, more or less. So it's not very big.
Yeah. That's
Yeah, I mean,
cool,
it's just I mean, it's a pretty small telescope. But yeah, they saw that flaw very, very early on, and
but they've had it fixed since then, and they got it
oh yeah,
to where they can see things clearly, and they can see a lot farther than they anticipated, I think.
the HST, as with every sort of upgrade in the technology, not only provides us with things that we think we want, but it provides us with things that we had no idea we wanted.
Right. So in comparison, if you take my little 90 millimeter matchcock that I have, and then I have the big Celestron 8-inch, okay?
Mm-hmm.
So the two different, you got 4-inch size and you got 8-inch size, I guess, if you want to go with inches. There's a big difference in the light gathering ability, but the basic technology is the same, correct? As far as the mirrored setup is concerned.
Correct.
Okay. That's interesting.
It's
and
just
then, of course, you look at the HSC or HST rather. You look at that, and it's like the same thing, only quite a bit larger than
it. Yes, exactly. Yeah, it's I mean there are sort of subtle differences, but the basic idea is exactly the same. So, yep, cool. Absolutely. Yep.
I don't know what you guys were talking about when I broke into the conversation, but anyway.
Oh, I have absolutely no idea. Yeah, no, we're just here,
hanging out.
As long as it's astronomy and space and science and nerdy things, I don't care.
Yeah, we're talking about stuff we know about somewhat.
Yeah, I'm going to check the chat because I haven't for a little while. So let's see. Astrolive channel, Chuck, Patrick, Uncle Bill. Uncle Bill says funding. Funding. Okay. What do you mean funding? Yes. I need funding.
Yeah. Earth Radio needs funding too. Wait a minute.
Yes.
I'm not advertising Earth Radio. But anyway,
we all need funding.
American Road Warrior, or Eric, you might know Eric.
I don't. Mm-mm.
He was a guest on my show. We have a talk the last Thursday of each month, and we talk about UFO cases. He's the state director for MUFON for Massachusetts.
Okay.
All right. So if you have a UFO case and you're in Massachusetts, then you would talk to him. And he'd say, "Hey, Eric, I got this UFO case for you," and then he'd investigate it. So anyway, that's what he does, and he is a guest of mine every month, once a month on the last Thursday of each month. So he comes on and we talk about interesting cases or a new case or whatever you might have a chance to investigate, and then we can talk about that. But he actually started playing some music today. I kind of got him set up on doing a little music stuff, DJing. So he's having some fun with that, learning about the little techniques about that, and just a little something for anyone that knows who he is would be fun to check out what he does.
Cool. Yeah.
And
nice.
Having a lot of fun with different people with their different tastes of music and talents.
Yeah. Well, it's good you're staying busy. I get the notification, so I'm fully aware that you're banging them out. So
yeah, because I know some people are saying they're not getting notifications, so I don't know what the deal is on that.
Oh, okay, yeah. Who knows? I can definitely tell you I'm getting them, and
okay, that's good.
I'm getting I'm getting at least a couple every day.
Yeah,
So,
I mean, I do mine in the morning time, and then usually Monday through Saturday I do mine in the morning time, and then Andy, he's in the UK. Andy Morrow, he will actually do one in the afternoon, and he just gets on and he wants to play, and that's what he likes to do, and he just plays. He plays
Right.
some strange music. He's in the UK, you know, so he got some strange music there. Tim might know about that one, right?
Okay.
Is that Tim that's over there?
No, that's Bobby.
No, in the UK.
Oh, yes.
Tim Robinson or whatever his name is.
I believe so. Yeah.
Yeah, he's in the UK. Yeah.
Yes.
So he knows about the strange music they have over there.
Strange music over there.
But Andy will play some weird stuff, but good stuff. I mean, always good as far as I'm concerned. It's always good.
So and when does his show?
Andy usually comes on in the afternoon when I get done. So I work until 9 my time until 11 my time, or maybe a little bit later than that. And then Andy will a lot of times come on in the early afternoon and play for a couple hours, and sometimes he'll play all day. It all depends on how it feels. So
I will have to come over and check it out at some point, because I'm totally into strange music. So,
yeah, he likes to play a lot of the club mix or the techno electro stuff, you know.
Yeah, all right.
And it's what you call trance music or dance music, whatever. I don't know. I don't know exactly what you call it. I don't pay attention to the name too much. I do like his music though; it makes you dance a little bit.
All right. Well, there's nothing wrong with pumping up the batteries a little bit.
Yeah.
So,
and then Amanda, you know Amanda. I think she is Mark's co-host actually.
Right.
She has a few shows on my station, and anyway, she played this morning before I played. She played. She played for a few hours, and I did.
All right, cool.
And so I'm always surprised to see other people just hopping on and playing, you know.
There you go.
I like that, though, you know. I appreciate that, because that shows that people care about it. They want to play.
Right.
And, you know, if you have a listener, great. If you don't have a listener, you'll hear it, you know, somebody will hear it later, you know.
Right.
And if you do have a listener, that's even better, you know.
Mm-hmm.
So I'm happy with that. And
very cool.
I know Bobby usually comes over there and listens, but he's been busy, I think.
Bobby's
really busy. I have been super busy lately. I've been catching up on my wrestling.
There you go. See, I thought so. I knew it. I knew you had a reason why you had been.
Constant, you might know Linux more than me. How can you force the deletion of folders that you don't need? Because right now I'm using the Graphico, and it's still saying preparing for quite some time. Oh, wait a minute, belay that.
If you go into a terminal and you do rm-f, I believe that forces.
Okay, what are you trying to do? What are you trying to close?
It's trying to delete some files that won't delete.
Oh yeah. Oh yeah.
So
sometimes that is a virus also. In some cases.
Yeah.
So be careful with that.
No, in Linux you won't get a virus unless you run it in root.
Oh, okay.
Yeah.
All right. Well, my laptop is still down. I'm waiting for them to. They offered to send me a new hard drive, and then of course I would have to replace the one in my computer, which means I would have to take it apart and replace it. But then I mentioned to the guy, emailed him back, and I said, well, I don't know if it didn't accept the software that you sent me. I don't know if it would accept a new hard drive if I got it all apart and then put it in there and then got it all back together again and it didn't accept it. Then what do I do? You know?
Oh, yeah.
So I suggested, why not just send me a replacement computer, the whole thing? You know, just send the whole thing, send this one back to the shop and find out what happened. I tried to work with it a couple of times and I get it turned on and it shows 0 mega. There's no hard drive installed, which I know is there.
Yeah.
Okay?
Yeah,
but
there's something.
But when it did list it, and it showed 0 megabytes were used. That means it was empty. So
Right.
why it was empty or why it was removed or whatever, however the
Yeah.
update did it was after the update of Windows 10 had
Yeah.
was. You know.
Have
So be careful with that. If you don't
Right.
know what you're working with on the update, be very careful with that. I know everyone has to get them, and a lot of times they're automatic, and sometimes you don't think about that, and you just go through your process, and then you wake up the next morning and something's not working right.
Yeah.
So
Yeah.
just be aware that could happen, and just be ready for that, or have a replacement or a standby or second plan. You know, plan B and C.
Plan B and C.
So make sure you got ready for that. And
Absolutely.
so,
Absolutely.
I've had it. Yeah,
So yeah, you know, it is clear here today, tonight.
Oh, nice.
And I'm not observing.
Huh.
So what's up with that?
Yeah.
Feeling a little out of place. But I think I started looking at the data that I got a couple of nights ago, and that data is looking really good. But I started looking at the galaxy images. I just wanted to do a quick stack, and my software is having some trouble stacking. So I'm not exactly sure what the problem is yet, because I just started looking at this late this afternoon. So not exactly sure what's going on. But here, I'll show you what I'm working with here. I don't think I showed any of these yesterday. So I keep pressing the wrong buttons. Okay, yeah, I'm ready.
I think the end of the month, the internet in general is having issues. Internet
you think so?
Servers, yeah, different servers, with different programs. They're doing their end of the month maintenance or whatever they're doing. I don't know what.
Yes.
And that could be some of the problem that some of us are suffering with on some of the programs not working correctly.
I gotcha. Interesting.
Because it does usually happen towards the end of the month, and then if you don't use your computer during that end of the month time, then you don't have to worry about it, then it's all done when you come back at the beginning of the month, and then but some of us can't do that. We have to use it every day.
Yes.
Okay, I cannot do an F flag at all with RMDIR. But it's still in the preparatory state for some reason. Oh, there. Now it finally did it.
Good. Now, Cosmic, if he pushes the wrong button and you disappear, something happens.
That's right.
So let's hope that Bobby don't push the wrong button.
Yeah, no, that, Bobby, I'm looking at the manual page for the command RM, and it is a hyphen F.
RMDIR. I didn't use RM. I used RMDIR.
Oh, so those are folders. They're directories.
Yeah.
Oh, okay. Yes. And I think you can use I think there's a hyphen F there. No, there isn't. Right.
Yeah. So it'd be better if I use RM, right?
Yeah, RM hyphen F, and then that'll actually get rid of the. That'll get rid of that too. So you're seeing that on my screen here. I was looking at the manual pages for RM, which is a Unix command, of course, to remove files. And there's Bobby, I would say RM hyphen F will also remove directories. I believe. I'm not going to try it. I don't have any. Actually, I can. Yes, I can. I can do make your test. Right. So there's test. Oh, where is it? L test.
No, you didn't.
Oh, where is it? Weird. It says file exists.
I don't like Unix.
There it is.
Too much
Oh,
work.
yeah. I see what it's doing. It's actually listing the contents of the directory called test. Anyway, so I could do an rm-f
Not
test.
Unix, but what you said.
I think you got to do an rf. Yes. Yeah. Sorry, Bobby. It's a rm-rf.
Okay, so what's the difference between F and RF?
An R is a recursive deletion, so that actually removes the directories, and then the F is just the force. So no questions asked.
Okay.
So now he has to label the directory he needs to remove?
Yes.
Okay.
He needs to specify that, just like I did there.
Okay.
Anyway, so here's
yeah. Thank
you. So here's some M65 data that I took the other night. This is the raw data.
M65 is what?
M65 is a spiral galaxy
Ooh.
in Leo.
Okay.
And this is just the raw image here, so you can see, bad columns and weird things over here, and all that. But
the galaxy is that black spot there.
The galaxy is this blob right here. Yeah, and actually, in this image, the galaxy itself extends way beyond the edge of the.
I can kind of visualize that. Yeah, I can visualize that.
I don't know.
I mean, I can visualize it in a weird way. I can visualize it, meaning I can imagine. I can imagine it.
Yeah,
I don't think I can see it.
Yeah, I don't think I can see it either. So, anyway, the idea with stacking, right, is that I set a reference, and then every single image after that, I shift and rotate each image so it falls on the same location, right, and hence I stack. So, but I've got to use the relative positions of stars in the field of view to know how much to shift and how much to rotate. So in this case, I sort of have limited choices when it comes to stars. I basically have two that are relatively high signal to noise. These guys here, this one and that one, are just way too faint, right? I'm not really going to be able to do anything with that. I've got to be able to grab onto these things. So so my only real choice here is this star and this star, because they are the brightest ones, right? So that's where I think I'm running into a little bit of trouble. They're not easy to grab onto because they're pretty faint, and so my stacking program is having a little bit of trouble with this galaxy, and so as a result of that, I sort of opted to try to figure this out and see if I could, I guess improve the code enough to be able to deal with this. So that basically means I really don't need any new data at this point. What I was going to do tonight was actually look at a couple more galaxies, and also look at another eclipsing binary star, which is kind of an interesting one. I want to actually show you all of that as well. But yeah, so I'm kind of stuck on this at the moment. I want to see if I can stack these, sort of the way that I want to. If I can't, then I either have to come up with another way to stack them, or I need to come up with some kind of observing method that allows me to stack. Maybe I'm going to be limited to galaxies that have some pretty bright field stars. So yeah, because I'm not having any trouble with any of the other data at all. I've got some nice bright stars right in the fields of view, and I'm locking onto those, and stacking looks great. But I'm having some trouble with this one, and like I said, I think it
looks pretty dim in the view that I'm looking at on some of the examples on the pictures that I see here on the Google Images.
Yeah. Well,
it's looking pretty dim for. I mean, I'm sure that you can see it and say, "Wow, that looks great." But then if you try to I don't know if you can improve on that or how you can make that any, because it is pretty dim from what I can tell.
Yeah, well, the galaxy itself, I don't really care how bright or dark it is. I chose this one because it is, I guess, relatively speaking, pretty bright. So a little bit easier to work with, but yeah, the my software is, I think, having some trouble locking onto these stars, right?
I can understand that.
Yeah, each image, it has to find those two stars, and those two stars could literally be anywhere. So it's got to do some pattern matching stuff, which is it's an interesting programming challenge for sure. But yeah, it's just not. It's just, I don't think that it is properly detecting the locations of these stars. It's getting close, but the resulting stack is not very nice looking at all. So yeah, I either have to get my code to work on this. So I have to give that a chance. I have to think about other ways that I might be able to stack. I was thinking just before we came on to the live stream that I actually have some pretty constant points. I have the exact center, and I have the four corners, and I know where those are all the time. So I might be able to use that information. Don't know. The other alternative, as I said, is in the observing technique itself. Maybe, I'm not going to be able to look at just any old galaxy, but I'm going to have to look at galaxies that are next to, pretty bright stars. These stars, this guy, I'm going to estimate is probably around maybe 12th or 13th magnitude. This one's probably around 12th or 11th or so. So, they're both relatively faint. It'd be nice to have a couple of 9th or 10th magnitude stars in here. I think I'd be able to grab onto those much better. And of course, these guys are even fainter, right? They're probably 13 to 14. So, and there's just nothing to grab onto there. Their signal is very low, almost in the noise, right? Almost in the noise. So yeah.
On a normal stacking procedure, if you have the proper pointing stars, so to speak, how many times would you need to stack it in order to get the quality picture that you need?
Well, the point for me to stack is to increase the signal to noise, right? So as I stack, the signal just adds, but the noise adds to the square root of the noise. So as you add more images, your signal to noise just naturally goes up. So that's what I'm after is maximizing signal to noise. Okay. So in my case, the more images I have, the better, right? If I could have thousands and thousands and thousands of images, that would be great. But I mean, each image takes a certain exposure time and then a certain amount of time to download. And so I don't remember what these are. I think these might be 3-second exposures, and then I think it takes about 3 or 4 seconds to download. So I'm getting an image, every 7 or 8 seconds. And I think in this case I grabbed 200 images. So let's see. So 200 divided by, let's just say 8, which it's probably 7. So that took almost half an hour, right? 28 and a half minutes or so to grab 200 images. And I think the 200 images, I think that what it's going to look like, if it's properly stacked, I think it's going to look absolutely fabulous. I think we actually probably are going to see this galaxy extended quite a bit out. Just in my really crummy stacking of the first 20 images, the galaxy I can see all the way out here. So I've got 10 times that many images to actually stack. So I'm thinking, in terms of what it's going to look like, I think it's going to look really nice. I'm hoping then, to measure the magnitude of the nucleus and maybe the magnitude of various regions of the galaxy. See what they show, right? I have no idea. But yeah, so having some trouble with the stacking. Like I said, I've got plans to solve that problem. Might not be able to do it in software, but so yeah, that's sort of because I sort of have this obstacle. I've got to deal with this first, right? And so there's no point in taking any more galaxy data until I resolve this. So yeah, but actually the other target is this pretty interesting eclipsing binary star. It's called HW Virginis, right? It's in the constellation of Virgo. But what I found astonishing was the period. It's 2.8 hours, right? So every 2.8 hours, you get a dip in the light curve, right? It goes from magnitude 10.48 almost down an entire magnitude to 11.38. So that's a very dramatic.
Wait, that's two stars that are
yes
going around each other.
Yes, every
or one star going around the bigger star, obviously.
Either, but, yeah. You know, they shared some kind of Berry center, so yeah.
Wow.
You know, they're sort of, but yeah, they are going around each other every 2.8 hours.
Wow.
So that's just absolutely crazy.
I think about Mercury. We think about Mercury. 88 Earth days go around the sun.
Yes.
Okay, now that's pretty quick on its own.
That's very quick.
Think about how many times did you say now?
Every 2.8 hours.
Wow.
Yeah. So that's like, you know, what, 8 times a day?
Wow.
Yeah. Yeah. So the eclipses occur very, very often, and they're very, very fast. Here's a list, right? So
what would that be like to be on that?
You know, I can't imagine what that would look like, right? And the interesting thing is that I think if I'm reading this right, these are 2 dwarf stars. There's some kind of subdwarf and some kind of M dwarf. So you know, these are this is actually kind of an interesting system. I was looking at the Simbad.
That would be two collapsed stars then?
Well, you know, no, just small, right?
Okay.
So you know, perhaps like a white dwarf and an M dwarf. So
they would be still bigger than our star, right?
No.
Or smaller than our star.
Much smaller. Okay. Much smaller. Yeah. White dwarf stars, for instance, are on the order of, you know, maybe half a solar mass up to about 1 solar masses, but they're about the size of the Earth. So they're extremely small, extremely dense objects, or so the story goes, right? You know, that's our current understanding. M dwarfs are just very, very low mass stars that you know, are just big enough to glow, right? You know, they're doing, you know, whatever they're doing, you know, either fusion in the center or, you know, something. Anyway, they're glowing, right? And so these 2 objects are going around each other, right? And there's a bright one and a dark one. And as they go around each other, it just so happens that from our line of sight, the dark one passes in front of the light one every 2.8 hours. And we can see that, right? And so, yeah, here's a listing of those events. So the first column here is just the Julian day, right? But then you've got these 3 columns here, right? So this first column, that one, say, is when the eclipse starts. This column is when the eclipse is at its maximum, right? And so the brightness of the star is at its dimmest point. And then this is when the event ends. So as you can see, you know, let's see, it's 3 hours UTC right now. So in 54 minutes, there's going to be an eclipse, right? And it's going to go from 3:54 to 4:14. So that's 20 minutes. So it's a 20-minute eclipse. That is fast. That's just mind-blowingly fast. So I think
the
I'm
one
probably
the one that's getting eclipsed is the brighter one.
that's
right?
Well, you know, when an eclipse isn't happening, you're seeing the light from both of them, right? But when the eclipse is taking place, you're basically just looking at the light from one of them, right? The darker of the two. And that's why it gets fainter, right? I mean, it looks like it gets fainter because you're looking at just the light from the darker of the two stars. In this case, probably the M dwarf, right? It's much darker. So, yeah, it's just it's amazingly fast, and this is the time of year when Virgo is rising. So, so there are actually sort of multiple opportunities in one night, to catch these eclipses. So, if I were out tonight, I would definitely get that one, right? Definitely. I might, if I wanted, to stay up, I could get that one too. And if I really wanted to stay up, I could get that one. So I could potentially get three eclipses in one night, right? If I were willing to stay up.
Like to welcome Deep Sky Dew in the chat.
Hey there, Deep Sky Dude. So we are looking at a really interesting
Now,
eclipsing.
is there any with that binary system? Is there any movement in the primary star, like on a star, when you notice that it has a planet around it, you see what they call a wobble?
Yep.
Is there a wobble around that star with the binary star system?
That's one of the really interesting ways. Here, I'm going to get myself back to that. So what you mentioned is actually what's done to see if there are other players involved in the system. Because what you can do, right, is you can take your best guess in terms of an orbit, right, and you can make a prediction and say, okay, like according to the orbital parameters that I have, I plug this into my model. I can generate a light curve, and I can predict when the faintest point is going to take place, say. Okay, that's sort of a nice measurable place. Sometimes it's kind of hard to tell when it's starting and when it's ending, but it's pretty easy to see where it bottoms out, right? So your model can predict that, right? And then you make an observation or a series of observations, right? And you match the timings of your observations to the model and see how close they match. And in a lot of cases, there are discrepancies that are sort of periodic, right? So what that means is that there's a third player in there, or a fourth, or a fifth. Who knows, right? But by looking at those differences over time, and again, you just need a lot of time, a lot of observations. You can actually at least get some indication that there's something else there, right? You might not be able to tell exactly what or where it is or anything else, but because of the differences between sort of your perfect model and the observations, if there's a discrepancy there, well, something is causing that. Maybe your model is wrong, right? Maybe you made a typo in the code, and one variable name is just slightly off, right? Could be lots of things. But
the other question I would have is, what about them colliding? Is that possible that they would merge?
Yeah, a lot of the systems that are eclipsing binary stars actually share or are in contact, or they share some kind of common atmosphere. Mm-hmm. So yeah, because these guys are for the most part, and this is sort of the characteristic of these kind of eclipsing binary stars, and that is their periods are very, very fast. Usually it's days, right? But even that is really, really fast, right? Like you pointed out, Mercury's orbit is 88 days. Venus is something like 147, 144. Earth is 365. Mars, I don't remember what Mars is. It's 500 and something. I don't know. But yeah, these stars are going around each other in days or hours. So yeah, it must be an incredibly epic view. Yeah, I'd like to.
If we're looking at our sun from out in space, say from where Voyager is, Voyager 2 went out the other way to the edge of the solar system. Was Voyager 2 that went out that way, or was it 1 that went out that way? I don't know. Anyway, one of the Voyager.
They're both out there.
The one is at the edge of our solar system, our solar gravity.
Yep.
If you look at how far that is, now you're looking back at the sun, can you see that wobble with our planets? Like, I guess Jupiter and Saturn would probably be the biggest ones that would cause the swing, but I think if they're all in line on the same side of the sun, you definitely see some kind of movement with the sun's position, correct?
Yeah, it's very, very subtle. I think the entire mass of the solar system is something like 1% of the mass of the sun. So it's I mean, there is definitely for sure a wobble. Okay. I don't know if it's in any way measurable.
Okay.
Yeah, that's an interesting question. I mean, I'm thinking about it, and it's like, well, we should. I wonder if there's a way to measure that from Earth.
I don't know if we'd be too close, really.
Well, I think the closer the better, right? Because of the wobble.
Then what about the SOHO satellites, the Solar Observatory satellites that are orbiting on each side of the sun? Wouldn't they be able to tell a movement or some kind of wobble or some kind of? That'd be an interesting thing to ask somebody, whoever would have that information.
You can actually get the. I think that you could probably get a pretty good idea as to the location of the sun in the sky for any time. Actually, looking at the SOHO LASCO images, those wide field images.
Yeah.
Because you can see the stars in the background, so you can use the background stars to to know what the position of the sun is, right?
Oh, yeah.
You know, to the accuracy of the detector, and you could do exactly the same thing. You could compare your measured position to some kind of calculated position and see if there's a difference.
Oh, okay.
I like I said, I'm not sure if that's. I mean, there would definitely be a wobble, but I don't know what that would look like. That's a pretty interesting thing. I don't think I've ever heard of anybody working on that kind of thing. So
I wonder what the UFO, with the aliens visiting us, if there's such a thing. If you think about the UFOs that we supposedly see, the flying saucers or alien craft of whatever kind, shape you want to talk about, but you think about, why are they visiting? Do they see our sun, and do they see it moving? Do they see a transmission from something we're sending out there? Did they run across one of our spacecraft out there? And we need to find that planet Earth, I mean, like they sent in the Voyager, didn't they send something kind of like a message or something on a
there's a
whatever it
record,
was,
yeah,
a record of some
there's
sort.
a record on it, yeah.
Yeah, and then they had some kind of message that they had written on there, different languages. I don't know what they had written on there, but
yeah,
it was
some kind of
weird.
Yeah.
And now, do you really think they're gonna read that and say, "Oh, we should go check that out"? And then
I don't know. We're thinking. We think that physical law is universal.
Okay.
Right. And if that's true, then some pretty basic concepts are also universal. Right. Like pi, right? The ratio between the circumference of a circle and the diameter.
That's from our perspective, though.
Well, but that's if we assume that circles and lines are sort of universal, right? That they exist everywhere, then probably those kinds of things have been encountered by any kind of intelligent life, right?
Yeah.
So that intelligent life has some kind of concept of pi, right? Now, it might not be what we think, the numerical value is, right? And because that's sort of a cultural thing, right? But the ratio between the circumference and diameter of a circle is this thing.
It's the same, yeah.
Right?
So the speed of light. So the speed of light is going to be the speed of light.
The speed of light is probably the speed of light.
Going to be the same.
And things have a particular size, and chemistry, right? Chemistry is going to work about the same. Now, it might be a wild assumption to think that there are universal laws. We don't know that, right? But if we assume that, then any kind of intelligence out there is going to have the same kind of understandings that we have, and so that is the basis of communication, right? So what that record shows, in the best way that we can explain, are some of these concepts, right? Because as soon as you can get some very, very, very basic concepts down, like logical concepts, right? Once you have logic, you're done, right? You can fully communicate.
Yeah. And this professional noob called Your Boy Codes needs to apologize for a racist word.
Oh yeah? Your Boy Codes? All right, well, Your Boy Codes, you need to behave if you're coming in here. So, you know, we're talking astronomy, space, science, nerdy things like that. And not necessarily interested in anything else. Sometimes, you know, we go off on a few tangents, but yeah. Well,
we're talking science here.
Science.
But yeah. So then basically we can assume that water is water.
I hope so.
But now, you know, like you're drinking water there, H2O. Now,
HOH.
Oh. But so then you on Mars now they found water. They actually found water on the moon.
Oh yeah.
But it's not the same type of, you wouldn't want to drink it.
Well, I'm sure it probably has to be cleaned up a little bit. There's a lot of dirt on the moon.
Right. and of course we know it's a bell, it's hollow, so it can't have any, you know, it doesn't have any real mass to it, you know.
It's just a big vessel of water.
Big bell with a lot of computer stuff inside of it, they say.
That's it. All the cameras coming out and everything. Right. Yeah.
They've been watching us and all this time. Oh boy.
Well, that's all right. I have no problem. You know, here again, I have absolutely no problem thinking about the concept of humans having a moon base right now. I mean, I think that the military, I think it would behoove the military to have some kind of lunar base. And I don't see what the big deal there is either. Anyway, yeah.
There have been quite a few movies about that were kind of interesting. There's somewhere they had Nazi base on the far side, you know, and nobody knew about it until they landed there and found them. It was like, oh crap, we're in trouble now.
Yeah. But yeah, you know, like I say, you know, we have to keep our minds open, and you know, I've definitely heard about, you know, the hollow moon and all of that, and I don't, you know, I'm taking the safe road and saying I really don't know. Right. You know, it's well, you know, one, I haven't investigated that all that much, so I don't have much to say about it at all. But I would definitely like to see, you know, that data that sort of indicates, you know, that what we think we have isn't. Yeah, I'd like to see.
I know that
kind of data.
I know that when the lake is frozen and you have that ice that's moving, you can hear the sound from the ice. Okay? So that's just the ice shifting and growing and expanding and contracting, and it's going to be making sounds.
Right.
Okay? I've heard that before, and I tell you, that is freaky.
Is it?
When you're thinking there's nothing there to make that sound, but yet there's a sound from this ice, you know, no way, you know, no way that you can hear that, but yet you're hearing it, and it's just weird. Which I could imagine that if the moon, for instance, if the surface is shifting or something's going on there that we don't know, you know, that could be any number of things that we're experiencing. I mean, we as in the human race was there. You know, we had a few people there that witnessed some things that they haven't even talked about, you know, but just from what people speculate. And
who knows?
You know, I think it's more speculation than anything in reality. And the ones who do know, they're not talking about it, and just because they look like they're crazy or something, and so they're they're keeping it quiet, you know. Which I can understand that.
I guess so, I think you know, I've been privy to some secrets, right? And they're all kind of silly, right?
Yeah.
It's sort of like, really, is that all? Right? So I think that it's a lot like that. I'm not exactly sure why it would necessarily be needed as a secret, to have a base on the moon. I don't know. I'm not quite sure what the necessity for secrecy there is. It seems like one of those silly things.
Yeah.
And that's why I definitely wouldn't be surprised if there are multiple bases on the moon, and we're going there all the time.
Yeah.
Fast, really
And
fast.
that was my suspicion that I thought that we were there. All this time we've been going back, and we've had missions there for whatever reason. I don't know why we'd be going there, except the fact to say that, hey, we're there and it's our moon and we're going to, take control of it and be part of this whole movement,
Right.
I don't know who could own it or who could be part of it or who could be the boss up there if everyone's doing the same thing.
Yeah,
like they made a big deal about Chinese landing the rover there,
Yeah, oh yeah, it's great.
And they successfully got it there and taking pictures and everything like that. And it was like, okay, we've had things up there before. We had the laser thing up there that was measuring the distance of the moon and everything like that,
Mm-hmm. Yep.
And so we had a few different scientific experiments that we've had up there that,
the Chinese have a telescope up there that's been operating for about 5 years now.
Yeah, and nobody says anything about that at this point.
Well, no, there are publications coming out of that group, showing data and all of that. So I mean, it's an active thing. I mean, it's a small telescope. It's working in the ultraviolet, but they're
cool.
they're doing interesting things that can't be done from the ground, for sure.
But I think if it improves our well-being, I think it's a positive thing to do.
Oh yeah, yeah. No, I mean, that space is where all that stuff is, and we are literally surrounded by more than we could possibly ever imagine to use. We could be as wasteful as we could possibly be, and we would never run out of stuff, right? So you don't even have to worry necessarily about conservation, because there's so much stuff out there. Right, so yeah, we need to get out there and get off of this extremely limited place that we have now, and I mean, I sort of say that in a weird way, because I mean, we haven't really gone inward, all that much. So what is inside the Earth? I don't know.
I think we should know more about home first, in my opinion.
I think that we should do both at the same time.
Oh, okay. There you go.
Yeah. We can do both. We can easily do both at the same time.
Different people that want to do each one.
Absolutely. Yeah. And switch off, right? These guys out in space, for 2 years, put them down in the ground for a couple of years, they'll get some good balance.
Yeah.
All right, everybody. Well, I think I'm going to get out of here for
and I think before we go, there was something, speaking of trolls and stuff, that I actually found I shared on Facebook about.
What's that?
Okay, so it says Perhaps the reason teens isolate themselves when they're overwhelmed instead of coming to us with their problems is because when they're toddlers, we isolate them when they're overwhelmed instead of helping them with their problems. When our kids are small and trying to manage emotions, they can't express what they are feeling. They throw tantrums, they throw things, they have meltdowns, they scream, they lie. This is their way of communicating with us. They need help to organize, process, and express their feelings in a healthy way, and society tells us we should punish them for this. Send them to their room, put them in timeout, spank them. When, okay, we teach them to train not to show their emotions, don't whine, don't complain, your feelings are alone, be quiet. Eventually they'll start expressing their emotions to us because we told them over and over again we don't want to hear it. For so long they need to deal with it alone in their room, their chair, their corner. So when they turn to teenagers, we expect them to feel safe talking to us, and tell them that it's now okay. But they think the opposite because this is what they grew up learning.
Interesting, yeah.
You want to give your child permission to feel. Let them know their feelings about it, that you care, no matter how small. Make sure that they are heard. Pretty soon, meltdowns over crayons turn to breakups, heartbreak, sex, or even depression. You want the child to know that you always hear them, no matter how small. You are their safe space.
Absolutely. One of the what you're reading there reminds me of the philosophy of one of the great humans of all time, and that is Fred Rogers, right? Mr. Rogers.
Yeah.
Man, he had things figured out, and what you were reading there, right, is almost verbatim what Fred Rogers was saying in the 60s and the 70s, right? I heartily agree. I totally agree. I mean, I think we should listen a lot more than what we do, for sure.
Yeah.
That's hard, because we have our thoughts and we have our, all of that. But listening is when you're a musician, right, playing in a band, you got to listen, right? You can't be, going off into la la land, right? You got to be listening to everybody, especially when you're jamming, and really, in a certain sense, that's what we're doing here, right? Is jamming, right? We're just doing whatever, right? And so you've got to listen, right?
Oh yeah.
So
Yes.
yeah, I totally agree with that, Bobby.
Well, thank you for the show tonight. Thank you, Bobby, for being here.
Yeah, I think I'm gonna get on out of here for today. So yeah, I want to talk a little bit more about H.W. Virginis, because this is actually it looks like a fairly well studied object, and I want to dive into it a little bit. It's fascinating, right? This very, very rapid orbital period, 8 times a day, and I think the components are kind of interesting too. So I want to get into that a little bit as well.
Right.
So all right. Well, for now, I'm going to get out of here. Peace, cheers, and all of that. Make sure to subscribe if you haven't already. Hit the thumbs up if you so desire. Make some comments. Spread the word. Right.
And,
I'm
friend.
here. Just tell a friend. And I'm here just sharing a passion. Right. I'm not here to communicate science. I'm not here to teach, right? You're just sort of jumping onto my train, and we're going. That's about it. So you'll learn things, and things will be communicated, right? But that's not what I'm doing here at all. I'm just sharing a passion. I love astronomy. I like science. I like all the nerdy things, and you know, this universe fascinates me, and so I want to know as much as I possibly can. Don't expect to get any big answers or anything, but yeah, I just like to know stuff. So, all right, I think that's it for now. Peace, cheers. Take care, everybody. I will see you tomorrow. Might be obsession tomorrow. I will keep you posted. It's supposed to be clear, so I don't know if I'd be able to go 2 clear nights in a row, you know, with no moon out. That's just too tempting. So I'll probably come up with something. So
All right.
all right, everybody. I'll see you later. Bye.
Bye-bye.
Later.